Outcome 1, factors, multiples, and roots. Students will demonstrate an understanding of factors of whole numbers by determining the prime factors, greatest common factor, and least common multiple, square root, and cube root. Multiples and factors. A quick review from earlier math. The multiples of a number are determined by multiplying the number 1, 2, by multiplying the number 1, 2, 3, 4, and so on, or by skip counting. So for example, the multiples of 12 are 12, 24, 36, 48, and they will continue indefinitely. Multiples that are the same for two numbers are called common multiples. Determine the first three common multiples of 4 and 6. So to find the first three common multiples, we're going to start by listing multiples of 4. So 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. And if we continue to skip count, we have 15, 18, 21, 24, 27. Skip counting by sixes, 6, 12, 18, 24, 30, 36. We're looking for the first three common multiples, so let's see what we have if we have any repeats yet. And we do. We have a repeat of 12, so there's the first common multiple. I have a repeat of 18, so there's the second common multiple. And I also have a repeat of 24, so there are my three common multiples of 4 and 6. A factor is a number that divides exactly into another number. For example, 1, 2, 3, 4, 6, and 12 are the factors of 12. Each number divides into 12 with no remainder. Factors that are the same for two numbers are called common factors. A prime number is a number with exactly two factors, 1 and itself. Determine the factors of 40. So there's different ways of doing this. One way is to start with a factor of 1, and 1 times 40 gives you 40. Then we're going to move up and we're going to try 2. 2 goes into 40. 2 times 20 is also 40. 3 does not go evenly. 4 times 10 is 40. 5 goes evenly because 5 times 8 is 40. 6 does not go. 7 does not go evenly. And the next number is 8, which puts me at this end of my list of factors, and so I know there are no other numbers that will go into 40 evenly. Which of the factors are prime numbers? So from that list of 40, the only prime numbers are 2, 5, just 2 and 5. Those are the only two that can be found by multiplying them by only two factors. 1 times 2 is the only way you can get 2, and 1 times 5 is the only way to get 5. The prime factorization of a natural number is the number written as a product of its prime factors. So for example, the prime factorization of 12 is 2 times 2 times 3, or we can write it as 2 squared times 3. To avoid confusing the multiplication symbol with the variable x, we use a dot to represent multiplication. The first 10 prime numbers, so these might be useful to you, are 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. Natural numbers greater than 1 that are not prime are called composite. Every composite number can be expressed as a product of prime factors. Write the prime factorization of 3,300. So one method of writing the prime factorization is to make a factor tree. To make a factor tree, we want to find any two numbers that multiply together to give us 3,300. So I'm going to start with 33 times 100. I then need to check and see if those factors are prime. So 33 is not prime because I know that 3 times 11 will give me 33. 3 is prime and 11 is prime, so that branch is done. 100, though, will break down into 10 times 10. 10 is not prime because 10 is 2 times 5. 2 and 5 are both prime. I need to make sure that I factor this other 10 as well. And then I'm going to write out my prime factorization by listing the factors. The smallest factor that I have there is 2, and I have 2 of them. I also have a factor of 3. I have 2 factors of 5 and a factor of 11. If we multiply all of those numbers together, we should get back to 3,300. If we don't, it means that we've made an error in our factor tree. We can simplify this answer a little bit more by just writing it with exponents. So 2 times 2 I'm going to write as 2 squared. Then I have times 3 times I have 2 factors of 5 and a factor of 11. The greatest common factor of 2 or more numbers is the greatest factor the numbers have in common. For 2 or more natural numbers, we can determine their greatest common factor, or GCF. Determine the greatest common factor of 138 and 198. So we can do this like we did in the introduction, where we write out all of the factors. Or we can use a factor tree and prime factorization to help us. So I'm going to start by prime factoring 138. So I need to start by finding 2 numbers that go into 138. Because 138 is even, I know that it's divisible by 2. So 2 times 69. 2 is prime. 69 is divisible by 3. So 3 times 23. 3 is prime, and so is 23. Now I'm going to prime factor 198. Again, looking for 2 numbers that multiply together to give me 198. Because it's even, I know that it's divisible by 2. So 2 times 99. 2 is prime. 99 I know is 9 times 11. 11's prime, but 9 is 3 times 3. Writing out the prime factorization for 138, I have 2 times 3 times 23. Sorry, for 138. For 198, it's 2 times 3 squared times 11. To find the greatest common factor, we want to take the prime factors that are common in both of those groups. So both of those groups have factors of 2, and they both have exactly 1, 2. So I can take 1, 2 as a factor of my greatest common factor. They also both have 3's as a factor. One has 1 factor of 3, the other one has 2 factors of 3. The only thing that's exactly the same in both is one of those 3's. I have no other factors that are common to both sets of prime factorization, and so my greatest common factor is 2 times 3, or 6. How would you determine the greatest common factor of 3 numbers? The beginning of your process would be exactly the same. You would prime factorize them, and then instead of looking for things that are common in 2 sets of numbers, you would have to look for factors that are common in all 3 groups. The least common multiple of 2 or more numbers is the least number that is divisible by each number. We can determine the least common multiple of 4 and 6 by combining identical copies of each smaller chain to create 2 chains of equal length. So the red chain has 4 blocks, the blue chain has 6. And if we continue to combine those, we can find that it will take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 blocks to make identical chains. The shortest chain possible is 12 cubes long. So the lowest common multiple of 4 and the lowest common multiple of 4 and 6 is 12. Determine the least common multiple of 18, 20, and 30. We don't want to be digging out blocks all the time to be able to find the least common multiple. So another way of doing it, again, is to start by prime factoring. 18 is 9 times 2. 2 is prime. 9 is 3 times 3. So the prime factorization of 18 is 2 times 3 squared. Then if we do 20, 20 is 4 times 5. 5 is prime. 4 is 2 times 2. And the prime factorization of 20 then is 2 squared times 5. The last one is 30. 30 is 6 times 5. 5 is prime. 6 is 2 times 3. So the prime factorization of 30 is 2 times 3 times 5. When we are looking for the lowest common multiple, we are looking for the most of each factor that's present. So my first factor is 2. I have 1 2 here. I have 2 of them here and only 1 here. So the most that appears are 2 factors of 2. My next factor is 3. I have 2 3s here, 0 in the second set, and 1 3 in the third set. So the most 3s are 2. I have no factors of 5 in the first set, but I do have a factor of 5 in the second and a factor of 5 in the third, and so we're going to take 1 factor of 5 into our lowest common multiple. Multiplying that out, we end up with 4 times 9 times 5, or 180 being the lowest common multiple. Are there any pairs of numbers for which the least common multiple and the greatest common factor are the same number? Explain. This is a great level 4 question, and I'm going to leave you to do your practice and think about the answer.